Hi guys, I'm Julian. I'm the TA of your class CS4379, and today I want to make a short mini tutorial about recursion for some of you who has a little struggle with recursion or just want to have some refreshment over this topic. And I want to demonstrate factorial calculating factorial of a non-negative integer n as examples using recursion method. So, so just want to recalling from math, a factorial of n denote at n exclamation mark. So the formulas of n factorials equal to n times n minus 1 times n minus 2 times until we reach 1. So let's say we have a factorial of 5. We have 5 times 4 times 5 times 4, which is 5 n minus 1 times 3 n minus 2 and 2 and 1, right? So this is a very good example for recursion because if you think about this, a 5 would equal factorials of 5 equal to 5 times the factorials of 4. If you think about it, 4 factorials equal 4 times 3 times 2 times 1 and 5 and will equal to 4 times 3 factorials, which is 3 times 2 times 1, and we go on like that. So pi equal 5 times 4 times 3 times 2 and 2 1. So using this observation, we can definitely build a recursive functions on this kind of concept. So if you look at the base case, so the base case is the case where you cannot make any is you can think it is the simplest case or in some case that you just cannot make any more subsequent recursive call after that. So let's say 5, so say n equal 3. So if you if you think about we have 3 factorials equals we have 3 factorials equal 3 times 2 times 1. We we able to make some recursive call with 3, which is 3 times 2 times 1. So it is not considered as a base case, but if we have 1, so say 1 factorial is 1 times 1, which is 1. So obviously we can just make any a more recursive call on 1 because 1 factorial is 1 it is itself. So the base case in this factorial problem is 1. So 1 is where the recursive call should stop and post that start to call. So we have a recursive call which based on this. So we have say factorials of 5 when after that, so 5 times 4 times 3 times 2 times 1. And the building up solution, we would have this 5 when which we explained earlier. So we have 5 times 5 factorials equal 5 times 4 factorials and 5 times 4 times 3 factorial and so on. So this is how you determine the base case, the recursive calls, and the build, and when you're building up the solution for these factorials, and let's apply this into the code. So where you have n equal 1, we would like to return 1 because factorials of 1 is 1. And for the recursive call, you want to, if you look at this, it will call itself. We would have n and call nth time to a function that call itself, right? So because we have n's, in this case we have 5 times of factorial of 5 minus 1, which is that. This is actually, and this will keep going like this. So 5 times 4 times factorial of 4 minus 1, which is 3. And we keep going until we reach 1, which is a base case. So factorial and minus 1. So what happened here is when we reach into 1, the cost that we will have 5 times 4 times 3 times 2 times 1. So when we reach 1, when there's we reach the base case when there's no appropriate end to returns or to end to call another recursive call, we will reach to the end of function, and that is when the stack to get up. So we would have 1 times 2 times 3 times 4 times 5. Each of this will just pop out this recursive stack. So we have 1 times 1 just cut off the stack, times 2 cut off the stack, 3 pop the stack, 4 pop out the stack, and 5. Then we will have the result because of they just multiply each other. So that 120. And then okay, so right, let's test another case. So tutorial uh 4. Let's see. All right, guys. So if you have any questions, just post on Piazza, and I'll definitely reach out to you. So thank you very much.